Hi friends, today we are going to see the 11th standard physics unit 1 nature of physical world and measurement from the Tamilnadu syllabus. So we will see the chapter step by step. So first we will see what is science. The word science has its root in the Latin verb scientia meaning to know. In Tamil language, it is called as Ariviyal, meaning knowing the truth. Knowledge of science dealing with non-living things is the physical science, that is physics and chemistry, and that dealing with living things is called botany and zoology. Curiosity-driven observations of natural science Curiosity-driven observations of natural happenings was the origin of science. The word science was coined only in the 19th century. Natural philosophy was the earlier name given to the science. Egyptians have played an important role and have given a lot of contributions to the science. Scientific and mathematical excellence in India dates back to the Indus Valley civilization, dating back to 3300 to 1300 BC. The scientific method, so in science we have to prove everything based on a scientific method. So when you are saying scientific method, it's a scientific method, so we are trying to say what is a scientific method. The scientific method is a step-by-step approach in studying natural phenomena and establishing laws which govern this phenomena. Any scientific method involves the following features: systematic observation, controlled experimentation, qualitative and quantitative reasoning, mathematical modeling, predicting and verification or falsification of theories. So an example has been given to explain what each of these is. A systematic observation. Consider a metallic rod being heated. When one end of the rod is heated, the heat is felt at the other end. So the following questions can be asked on this observation. What happens within the rod when it is heated? How does the heat reach the other end? Is this effect true for all materials? If heat flows through the material, is it possible to visualize it? So these are all the type of questions that can be asked. So basically a systematic observation is something we have to observe certain things like falling off an apple was observed by a scientist. Similarly, a concept of heat or a concept of optics or anything like that is first observed. Then we are trying to do a controlled experimentation. That is, when we are saying a controlled experimentation, that is, we are trying to do it in a miniature environment, in a laboratory, by creating a similar setup. Suppose that is, we are trying to create a simulator setup, that is heating it. Suppose we are trying to identify and experiment a thermal phenomena. Now in this case we are trying to heat a metallic rod and trying to observe the thermal properties and thermal phenomena that is associated with this. Then we have to formulate then that is qualitative and quantitative reasoning. So what is meant by qualitative and quantitative reasoning? When we are saying quantitative, we have to do everything in terms of measurement. Suppose we have an earth here and we have a moon here, moon, earth here. Suppose we are trying to explain something, or we are trying to have a rod here, we are trying to have a rod here and it is heated. Here, and for example, when you are trying to explain weather in terms of earth or moon, the qualitative concept is we are trying to explain how much distance, when the distance is when the moon is near the earth, certain things will happen. when the earth is or when the moon revolves around the earth, certain things will happen. All these things can be said qualitatively, okay. But in terms of quantity, or when the rod is heated, this will happen, or it will get heated in certain amount of time, and all that things. But in case of quantitative reasoning, we have to tell exactly. Suppose we are heating a rod at say 200 degrees Celsius, 200 degrees Celsius for 5 minutes. How long it will take for the, suppose if the length of the rod is say 5 meter, 5 meter, how long it will take for the heat to travel from through a distance of 1 meter, how long it will how much time it will take for the heat to travel for 2 meter, or how much time it will take for the heat to travel to 5 meter. So we have to tell everything in terms of distance, in terms of time, in terms of temperature. So that is called as quantitative reasoning. So everything, telling everything in terms of numbers. Similarly, when it comes to moon and earth, we have to tell in terms of distance, time, everything. So that is called quantitative reasoning. So when after we say put everything in numbers, we have to make a mathematical modeling for that. So we will speak in detail about mathematical modeling in further chapters. Okay, that is creation of a formulas. Basically, for suppose when we are saying distance between moon and earth, we have to create some kind of a formula, mathematical modeling to create certain theories. Okay. Prediction, verification, or falsification of theories. So, and then we have to create some theories. Okay, the thermal theory, optical theory, etc. We have to create some theories based on the mathematical modeling only. Only when we have numbers, only when we have formulas, only then we can create theories. So that's what is being explained here. So all these constitute a scientific method of approach for any scientific experimentation or any scientific book. So all these steps have to be followed for any scientific approach to be followed. So all these steps have to be followed for any scientific method. The word physics is derived from the word physis, namely nature. The study of nature and the natural phenomena is dealt within the physics. Hence, physics is considered the most basic of all sciences. Then we have two important terms called unification and reductionism are the two approaches in studying physics. Attempt to explain the diverse natural physical phenomena with a few concepts and laws is called unification. For example, Newton's law of gravitation explains the motion of freely falling bodies towards the earth, the motion of planets, sun, motion of moon around the earth. That is, what they are trying to explain is, when we are saying the laws of gravitation, when we are saying a law of gravitation constitutes lot of things like earth, moon, planets, okay, planets, lot of planets around the earth, and a sun, okay, and a sun. So when we are trying to study about all these things, small things, all this. So we are trying to study the law of gravitation with all these things. That is earth, sun, moon, and the planets, etc. So all these are small constituents. Okay, all these are small constituents, which when we unify, we form the law of gravitation. Okay. The study of law of gravitation is one unifying factor of sun, moon, earth, and all these planets. So that's why it's called as a unification. So next we will come to what is reductionism. So when we are saying reductionism, suppose we will take this thermodynamic concepts, thermal engineering. Okay. So when we are saying thermodynamics, there are a lot of concepts involved like temperature, heat, entropy, enthalpy, and so many other systems are involved when we are saying thermodynamic concepts. So, when we are saying so each of these concepts like heat, temperature have to be studied separately, explained separately, and experimentation has to be done separately, and then we have to find the relationship between each of these. Okay, so this is called a major concept of thermodynamics or thermal engineering is divided or reduced into smaller concepts of heat, temperature, entropy, enthalpy, and all these subcomponents is called as a reductionism. Next, we will go to branches of physics. So, there are a lot of when you are saying branches of physics, if you see this chart, you will be able to clearly understand what is the branches of physics. So, we are trying to classify it as classical physics and modern physics. I hope you will understand this clearly. It's clearly explained here. We will see each of these, what each of these is in further chapters. Okay, classical mechanics, the study of forces acting on bodies, whether at rest or motion. Classical mechanics, the study of forces acting on the bodies, whether at rest or motion. Thermodynamics, study of relationship between heat and other forms of energy. Optics is the study of light. So we will study all these things in detail in the successive chapters. Scope and excitement of physics. So, discoveries of physics are of two types: accidental discoveries and well analyzed research outcomes. For example, magnetism was accidentally observed, but for the reason for the strange behavior of magnets was later analyzed theoretically. This analysis revealed the underlying phenomena of magnetism. Similarly, you also know that accidentally only gravitation theory was founded by scientists, and then later on it was analyzed and theories were formulated of gravitation. This analysis reveals that the underlying phenomena of magnetism. Albert Einstein equal to mc square, for example, the famous equation equal to mc square was a theoretical prediction in 1905 and experimentally proved in 1932 by Cockcroft and Walton. Theoretical predictions aided with recent simulations and computation procedures are widely used to identify the most suited materials of robust applications. Pharmaceutical industry uses this technique very effectively to design new drugs. Biocompatible materials for organ replacements are predicted using quantum prescriptions of physics before fabrication. Thus, experimentation and theory work hand in hand, complementing each other. So, first we have to form a theory, first we have to have an idea, then we have to do some experimentation, then we have to form some theory, then we have to prove. Then proving comes later. Only then comes the detailed experimentation and practical implementation in the industry. Physics has a huge scope, and physics has a huge scope as it covers a tremendous range of magnitude of various physical quantities like length, mass, time, energy, etc. It deals with a system of very large magnitude as well as very small magnitude involving electrons and protons. The range of time scale, astronomical range of time scales include, here we are talking about time scales. That is, it ranges from 10 to the power 18 per second to 10 to the power minus 22 seconds. So, next comes the range of masses. Range of masses from very small, heavy bodies of 10 to the power 55 kg. Mass of known observable universe to 10 to the power minus 31 kg is the mass of an electron. Then the study of physics is not only educative but also exciting in many ways. The most interesting is the designing of useful devices based on physical laws. For example, the use of robotics, journey to moon and to nearby planets with control from the ground, technological advances in health sciences. So all these are the scope and excitement of physics. Physics has a wide scope, and today the world, in today's world of technological advances, the building blocks of all engineering and technical education is physics. Physics in relation to technology and society. Technology is the application of principles of physics for practical purposes. The application of knowledge for practical purpose in various fields to invent, to produce useful product or solve problems is known as technology. So when we are saying technology, it is the application of the principles of physics. So suppose if we keep saying like application of heat, energy, etc., we have to the technology, the concept of technology explains where this is applied in the real world scenario. Okay, when you are saying energy, we can say it is a solar energy or wind energy or geothermal energy. Okay. Or when we are saying medicine, we have various applications of medicine like tablets, like the basic laws of electricity and magnetism. The basic laws of electricity and magnetism led to the discovery of wireless communication technology. The launch of satellites into space has revolutionized the concept of communication. Microelectronics, lasers, computers, superconductivity and nuclear energy have comprehensively changed the thinking and living style of human beings. Physics, the fundamental science, has played a vital role in the development of all other sciences. So we are just saying in physics in relation to chemistry. In physics we study the structure of an atom, radioactivity, X-ray diffraction. Such studies have enabled researchers in chemistry to arrange elements in the periodic table based on the atomic numbers. This has further helped to know the nature of valence and chemical bonding and to understand the complex chemical structures. So I think you'll be able to understand the relationship between physics in relation to chemistry. Okay. Only when we observe using the technology of physics, when we observe the atom, when we observe the electrons and protons and through X-ray diffraction and radioactivity, we will be able to analyze and find out the chemical properties. Physics in relation to biology. Biological studies are impossible without a microscope designed using physical principles. The invention of electron microscope has made it possible to see even the structure of a cell. X-ray and neutron diffraction techniques have helped us to understand the structure of nucleic acid. So X-rays, we know it has a wide application in medical sciences. So when we are saying coronavirus, we observe that virus, we make experimentation using lot of equipments which is made up of the physical principles, which is made using the physics principles. Especially the microscope, electron microscope, which is able to observe the smallest of the viruses and cells in of the cancer and other diseases. Physics in relation to mathematics. Physics is a quantitative science, is most closely related to mathematics as a tool for its development. Physics in relation to astronomy. Telescopes are used to study the motion of planets and other heavenly bodies in the sky. Radio telescopes have enabled astronomers to observe the distant objects, distant points on the universe. The study of universe are done using physical principles. So using this telescope, observation of planets and studying its behavior is related to astronomy. Whereas to observe the planets closely and to know the inner details of it, we need a telescope. So So these telescopes are made using physics principles. That's what they are trying to say. Physics in relation to geology. Diffraction techniques help study the crystal structure of various rocks. Radioactivity is used to estimate the age of rocks, fossils, and the age of Earth. So, normally normally in temples, when we try to find out the age of a stone or statue in the temple, we say it dates back to 2000 years BC or 3000 years BC. We are trying to conduct certain experiments to find out the age of the statue or age of the tree, etc. So, when we are conducting such experiments, the instruments used for conducting such experiments has been created using physics principles. So that's what they are trying to say with respect to geology, physics and geology. Physics in relation to oceanography. Oceanographers seek to understand the physical and chemical process of the oceans. They measure the parameters such as temperature, salinity, current, speed, chemical and gas fluxes and chemical components. So in ocean technology is a broad area where we need to find out the temperature of the water at a particular location, or the wind speed at a particular location, and the salinity, etc. So I think you must have observed wind turbines in the ocean. So wind turbines are placed in the sea. So far it has not come to India, but I think you must have seen it is called as offshore wind turbines. So offshore wind turbines are placed in the ocean. Before placing it in the ocean, we have to take so many other checkings. How much depth we have to place the wind turbines at the ocean. At what is the temperature at that point? What is the salinity of water level at this point? So that how fast these wind turbines will get rusted. All these factors have to be taken into consideration. To measure all these parameters, we need physical machineries. That is, machineries which are created using physics principles. That's what they are trying to say. Physics in relation to psychology. All physical interactions can be derived from the psychological interactions can be derived from the physical process. The movement of neurotransmitters are governed by physical properties of diffusion and molecular motion. The functioning of a brain is related to our underlying dualism. So there's when a culprit is caught, and when the police investigating agencies find that he is saying a lie, then the thief is taken and experimentation is conducted, psychological experimentation is conducted to find out whether the person is saying the truth or not, truth or lie. So, and it is called as a lie detection test. It is called as a lie detection test. So, lie detection test is something related to finding out the inner memories or the past memories, and it is related to neurotransmitters. The instrumentation and the equipments is based on produced based on the physics principles. So it is related even to psychology also. That's what they're saying. Basically, it's a lie detection test. Nature teaches science with physics as an efficient tool. Science and technology should be used as a balanced manner so that they do not become weapons to destroy the nature. So we have atom bomb, nuclear bomb, etc. All these are the outputs of science. and we have guns, bombs. Okay, so we know how much of problems comes due to guns and bombs, nuclear bomb, atom bomb, etc. So that is the disadvantage we have, negative impacts of science. Measurement is the basis of all scientific studies and experimentation. It plays an important role in our daily life. Physics is a quantitative science. Physics always deals with the numbers, which are the measurement of physical quantities. Quantities can be measured. Definition of physical quantity. Quantities can be measured in terms of which laws of physics are described are called physical quantities. So when we are saying we have to measure something, in order to quantify something, we have to tell everything in terms of numbers. So the basic physical quantities with which we measure, we give the quantification is length, mass, time, force, energy, etc. There are many physical quantities. These are the basics. Physical quantities are classified into two types: fundamental and derived quantities. When we are saying fundamental or basic quantities, are quantities which cannot be expressed in terms of any other physical quantities. That is length, mass, time, electric current are basic quantities. Okay. Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Suppose area, volume. So when we are saying area, area is equal to A square. That is length into length. Okay. So length is the fundamental quantity. Length is the fundamental quantity. This is also a length. Okay. So when volume F is equal to ma, mass is the fundamental quantity. Acceleration, when we are saying acceleration, it is a derived quantity. Okay, it's a derived quantity. So acceleration, what is acceleration? A is equal to meter per second square. Meter is the fundamental quantity, second is the fundamental quantity. Okay. So acceleration is the derived quantity, mass and second. So that is time. When we are saying second, it is the time. Time is the fundamental quantity. So quantities that is these derived quantities are obtained using fundamental quantities. Definition of unit and its types. The process of measurement is basically a process of comparison. To measure a quantity, we always need to compare it with some standard reference. For example, when we state that a rope is 10 meter long, we say that it is 10 times as long as an object whose length is 1 meter length. So what they are trying to say is, here the 1 meter is the unit of, length. So consider a 10 meter, okay, we have to measure 10 meter, but we have a scale of 1 meter, okay, we have a scale of 1 meter. So we are measuring step by step, okay, and so this 1 meter scale, this 1 meter scale is the, when we are saying scale, it is, we assume that it is standard, okay, when we are saying scale, we assume that it is a standard quantity. Or when we are saying scale, we assume that it's a standard unit of measurement of length. So using the scale, we measure the distance. So this is a distance, okay, this is a distance, this is a scale. With the help of the scale, we measure how much distance is there. So that's what, so in order to measure how much distance is there or how much meter is there, we need something called a standard. So that's what we call as a scale or standards. That's what. So when we are saying, there are various types of standards which we'll be seeing it. An arbitrarily chosen standard of measurement of quantity which is accepted internationally is called unit of quantity. So when we are saying standard, the meter, 1 meter length in India should be equal to same 1 meter length in US or UK. So suppose in order to have that, we need to have a universal or international unit of measurement. So only then, suppose when we get a order, why we should have this uniformity is, suppose we get an order from the US or UK to make an object of 1 meter length, rod, okay, a steel rod of 1 meter length, and 1,000 components or 1 lakh components they are giving. Only when we have the same units of measurement, same units of length, same units of width, etc. 1 meter length in US, only if it is same in US and India, we will be able to manufacture and sell it. So that is the reason we have an international system of units. The different measurement systems, that is FPS system, is the British engineering system which is called as foot pound a second. Basically, foot is the length, mass and time. Foot is the length. When we are saying foot, it talks about length. When we are saying pound, it talks about mass, and second it talks about time. The CGS system is called the Gaussian system, which uses centimeter, gram and second. The MKS system uses meter, kilogram and seconds. The CGS, MKS and SI are metrics or decimal system of units. FPS system is not a metric system or decimal system. The SI unit of systems is used by scientists and engineers around the world. Is commonly used is the metric system. But since 1960, it has been known officially as the International System or SI system. So the name which was previously called as metric system is now called as International System. So instead of using the word IS, International System, it is used as SI. You have to observe this. The abbreviation of its French name, Système International. The SI, with a standard scheme of symbols and units and abbreviations, were developed and recommended by General Conference on Weights and Measures in 1971 for international usage in scientific and technical and industrial commercial work. So before 1971, each and every country in this world have been using different units. Yeah, 1 meter length in Africa and 1 meter length in US and India may not be the same. So only after 1971, they have decided to unify all these things and bring about a common standards. This system makes use of only one unit for one physical quantity, which means rational for units. In this system, all derived units can be easily obtained from basic and supplementary units, which means it is coherent. It is a coherent system of units. It's a metric system, which means that it is a multiple and submultiples that can be expressed in the powers of 10. The reason why it is called as metric is it can be expressed as multiples of 10. In SI, there are several fundamental units like length, mass, time, electric current, ampere, which you can just go through. We will be seeing all these things. And these are derived quantities and the units. Area, volume, length, etc. Pi is 180 degree. When you are saying pi, it is 180 degree. That is 180 degree, like a semicircle. So when we say 1 radian, it is 180 by pi. So when we are saying pi, we have to 1 into pi radian. We have to, that is 1 pi into 1 radian. 1 radian. We have to write like this. Pi radian means pi into 1 radian. We have to read this as not just pi radian, it is pi into 1 radian is equal to 180 degree. So 1 radian is equal to 180 by pi, that is 57.27 degree. 1 degree is the degree of arc. 1 degree is equal to 60 minutes of arc, and 1 minute of arc is equal to 60 seconds of arc. The relationship between radian, degree and minutes. 1 degree is equal to pi by 180 is equal to, we know that pi is equal to, pi radian is equal to 180 degree. So when you are asking what is 1, so we have to, when you are asking what is 1 degree, we have to write it as pi radian is equal to 1 into 180. Okay, that is 1 degree. 1 degree into 1 degree into 180 degree is 180 degree. So we have to write, for clarification I am writing like this for some students to understand. Okay, pi radian. So when you are saying 1 degree, so 1 degree is equal to 1 degree is equal, so 1 degree into 180 degree is equal to pi into radian. So 1 degree is equal to pi radian divided by 180. That's what. So we have to just, what I am trying to say is, we have to, when we are saying 180, we have to just think that into 1. You just assume it is into 1. Okay, 1 degree. 1 degree into, so 1 degree is pi by 180 radian. Pi by 180 radian, that is 1.745 into 10 to the power radian. Similarly for minutes, 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. When you say 60 minutes, I have told we have to just put it as again 1 minute. Okay. So now we have to find out 1 minute. You can put 1 degree divided by 60 minutes. So that's what they are, is written here. Similarly, seconds. The concept of length in physics is related to the concept of distance in everyday life. Length is defined as the distance between any 2 points. The SI unit of length is meter. For the objects of interest vary widely in size. For example, large objects like galaxies, stars, etc., moon, and the distances constitute macrocosm. It refers to large world in which both objects and distances and the distances are large. On the contrary, objects like molecules, atoms, protons and neutrons and the distances constitute microcosm, which means small world in which both objects and the distances are small size. I hope it is very clear. Macro and micro. Macro is used about the study of for large distances, and micro is to study about small distances. Distances ranging from 10 to the power minus 5 to 10 to the power minus 2 can be measured by direct methods. For example, a meter scale can be used to measure the distance from 10 to the power minus 3 to 1 meter. A Vernier caliper is used up to 10 to the power 4 meter. A screw gauge is used up to 10 to the power 5 meter, and so on. So each of these measuring instruments have a range. Okay, smaller range, that is when we are saying range, it is the smallest measurement and the largest measurement up to which it can measure. That's what I call as a range. Hence, to measure the very small and very large distances, indirect methods have to be devised and used. In table 1.4, a list of powers of 10 is given. So for smaller distances we use scales and so many other measuring units. For larger distances, what they are trying to say is we have to use an indirect method. That's what it's saying. Suppose we have to measure the distance between the moon and the earth, we have to take some indirect methods.